Hello again, my friends. Welcome once more to Leopard Street. This turntable. There's bits I've been wanting to do for it for a while. You may notice there's an extra track. This is actually now fixed in. We'll have a look at that as well. I've had this table turning noisily, which is why I don't connect the motor very often. I want to do something about that. I also want to make it so trains can actually run on it because I've got connectivity problems. So it's broke. Let's fix it, or at least try to. This is Leopard Street. I'd say how hard can it be, but I'm filming this at the end, so I already know all the calamities that are coming. I broke it. It will work again, honest. On with the show. Okay, so first of the two jobs to do. This, I've had this turntable working. You've seen in previous videos I can drive trains on. It made a hell of a lot of noise spinning. Not worried about the noise at the moment. Currently, I can't drive trains onto it. There is some sort of continuity fault. I've got a cat meowing at me. It's quite warm today. I'm filming this on the bank holiday Sunday. And yes, anyway, she's down here helping. I say helping, what I actually mean is not helping. Anyway, so the first thing I need to do is see exactly what the problem is here. Now, I suspect it's to do with these 2 points here. Just bring you up and have a little, you might not be able to see it. The way this turntable works, there is a split ring underneath here, and each rail has a spring and a little brass plunger that makes contact with the split ring. As you turn it round, it picks up the contacts. I suspect this is a little bit of a self-inflicted fault. When I painted this, I put a lot of wash on it. I think what's happened is I've got wash on the underside of the rail. Unfortunately, there's not a lot I can do about that because I can't take the rails out because they're stuck in. So what I need to do is a little bit of continuity testing with the good old multimeter. So bleepy, Mr. Bleepy is what we're going to do with. So what I need to do is see which rail has got, I know one of them's got contact. It's not that one, or at least one of them did have contact. Interesting. All right, let's turn it that way a bit. I should get a bleep at some point out of this. Now, it's actually quite hard to hold it to the rails. Interesting. Let me just check. Right. The various rails over there are working. The various rails here are correct as well. Right. Now, unfortunately, I can't quite get at the bottom bit of this. What I need to do is get at the end of the rail, I think, and see which one it contacts. Okay, I'm getting some very strange readings here. The readings I'm getting imply the table rails are connected together, but not very well. Right, there's no contact there. Slide it around to here. Now there is. Here, and contact disappears at that point. That makes sense. Around here, have I got contact again? I have. Okay. Okay, this is a little... This is not what I was expecting. I was expecting it to bleep when I connected it to one rail, but not when I connect it to the other. So I'm going to put it on the resistance range and see what reading I get. So if I touch that, it goes basically to nothing. So what's the resistance between there and there is that. Right, that's showing there should be contact there. So if I put it back on continuity mode, it's close. It's not quite where it needs to be. Why is there's quite a bit of resistance there? Okay, let's try it to the other rail. And that should be open circuit, but it isn't. If I put that way, this says there's possibly a slightly more fundamental problem here. I put that way so you can see this, and there's something about wires. Right, I do that. Right, so if I connect that to there, see, I can see it in the. I hate wires, I really do. Right, if I connect that to there, fairly low resistance reading, higher reading, but should be 0. And these two are showing a resistance between them, which not now. So put that there, that on top of the rail. Nothing. That's good. Okay, that rail. Nothing. That rail. Nothing. Try this rail. Right. Continuity there. Continuity there. Nothing there. Nothing there. Go back to that one. Okay. Try again. Yep. Yep. But not to that rail. And then this rail here. Should be nothing to that one. Try them to each other. Yeah. Right. Now. Okay. So, by the look of that, this side rail here is making contact. Well, it's a touch ropey. This side here isn't. Now, the way I fixed this previously, I don't condone this method, but if it works, it works, was to mess around with the spring under here a little bit and see if I could get it to make contact. I can hear that moving, so let's give it another go. Back on continuity mode. Again, see if we can get Mr. Bleepy to bleep. So that rail to that one worked last time. And now isn't. Try there. Nothing. And nothing. Oh, now I've got something. Now, one of the problems I've got, this turntable, it's a pain to take the bridge off. It is possible, but it's a pain. I think I'm going to have to do it, though. Yeah, so I'm going to take the bridge off, or at least I'm going to try to. I'll be back in a sec. Well, I've got the bridge deck out. Spot the missing part. Yeah. The pin came out, but it ripped itself free of the base of the turntable. Yeah, anyway, I've got the bridge deck off, which is the key bit. So you can see here the little plunger pickups, and here is the little thing they go to. I'm wondering about this. Now, I've seen Jace and his My Engage Dream channel. He's got the Engage version of this turntable, and he did something a little bit different with it. What he did was drill out the middle and fitted a split ring and soldered the rails to it. And I'm pondering doing the same thing. See, I can get at the underside of the rails. You can see the shiny bits there. I mean, I might have to cut one a little bit bigger, but I could solder some wires under there. Maybe. And then modify it. Basically, I'd have to cut out this center section. Yeah, basically take off this top plate. Yeah, I might be able to do it. I don't know. It's glued in. This is the problem. Take this center section out. I can remake a new shaft. That's not a problem. And if I need to, I can 3D print a piece to go here. The shaft really should go in a little bit further, but for some reason it doesn't. There's a plastic pin in there that holds it. But basically I could drill that I could stick another metal shaft in. That's not a problem. I can do that. Yeah. Anyway, before I do that, I'm just going to check these connect properly. That side connects to there. That side connects to there. You see, in theory, this method is actually pretty good. It gives you the continuity as you go round. So yeah, I think I'm going to have to drill that out though, and order some bits and get myself a split ring, and then basically totally rebuild the underneath of the thing for it to fit. So that's probably a job for another day. But first thing I'm going to do is I'm just going to confirm that these contacts here work. So what I've got is onto that rail and that pin. Yeah, it's saying nothing. That rail and that pin. Yeah. Basically, I'm not getting contact, or not good contact between this brass connector and the rail. Part of the problem with that, of course, is this is all glued together, so I can't actually get at this bit. But it is literally just a spring that's touching the bottom of the rails, which, I'll hold that up, you might even be able to see them. I'll hold that to the camera. They're tilted a little bit down those holes. You may be able to see the springs. And they don't make very good contact, it would appear. Which is a shame and a problem. But yeah, so that's the turntable broke. Oh, this is Leopard Street. Right, so that, I mean, this now, I did have an alternative, which is to take this out and get another one. The problem is they're not cheap. They used to be quite cheap, these things. They're about 20, 30 quid originally. They're now closer to 70, which is crazy altogether. So, I mean, they work, except for this one, which obviously doesn't. Yeah, so if I can replace the pivot mechanism on this with something else, I mean, literally, you're talking putting a shaft through it with a split ring section stuck to it. So what you'll have is that sticking out. You can see that. Bring it over here. That sticking out. It'll go through a hole in the board. There's a split ring that sits on it with wires that come to this. And what the split ring does, it's basically, you get them in 2, 3, 4 channels. And instead of having this sort of arrangement, it's 3 or 4 stacked rings with contacts that come in at the side, and they're much, much more reliable because they're sealed units. So I can see I'm going to be ordering one of those. So I think I'm going to go and do that. And the turntable project is going to be on hold until that arrives, which will probably be in a couple of days. Yeah, fair enough. Okay, I'm going to go do that. All right, at the desk. Now I've taken the bridge apart as much as I can. I've clipped the base plate off. I've taken the rails out. Now, what I wanted to do was slide the rails out. Unfortunately, I couldn't. So what I ended up doing was punching one end out through one of these holes, breaking some of the clips, and then just lifting them out. So there's one rail. This is what they look like on the underneath. Yeah, it's not really a surprise the spring couldn't make contact, really. I mean, it's sort of in around here, it's just painted over. So yeah, self-inflicted wound. I've cleaned the bottom of this one. The plan, such as plans go, I've ordered, and it's a slip ring, not a split ring, to sit on the bottom of this. So what I need to do, I need to drill this hole out to 4mm to take the shaft. That's fine. It can be slightly larger. It's going to get filled with araldite and a shaft glued through it. It's now going to be quite a long shaft, probably about yay. This will then have the slip ring sat on the bottom of it. That'll probably be glued to the shaft as well. I want to be able to take the bridge deck out somehow, so I need to think about that. But I'm going to use the slip ring as a bearing. It's the one I've ordered is 22mm in diameter. It'll fit on there easily. I may end up making a little plastic plate that sits on there so that it can sit. That's then got 2 fixed wires which will come in here somewhere. I want them to go through these 2 holes. I suspect I'm going to have to cut these down a little bit, because what I'm going to try and do is solder a bit of wire to this in the appropriate place, feed it through that. These rails are then going to get glued back into place because I've destroyed the clips. But they'll hold in place pretty accurately, I think, so a little bit of glue in there. I'm tempted to go with a smear of araldite and then a little bit of super glue in a few places. So like araldite at the ends, there and there, little blobs. And then I can put some super glue in the middle just to basically glue it in with, possibly right at the very ends as well. But the wire then goes through that hole, comes down here, or I'll probably cut a bit more of this away, and it can come out, loop around however much it needs to, go to the slip ring. Brilliant. The slip ring's then got other wires on the bottom. That then feeds through a new enlarged hole I'll have to drill in the turntable deck and into the plywood below it. If I don't glue the slip ring, I don't need to glue the slip ring to this. I mean, it'll rotate. I'm going to have to... It's a 7mm shaft, so something like that. This is obviously a 4mm, so what I'm going to do is 3D print a little sleeve, really, that'll go around it. It doesn't have to be that tight. Tight enough it'll act as a bearing, but not too tight. So, yeah. So I'm going to clean the other rail up, and the way I've done this is a bit of 400 grit paper, really. So just give it a quick whiz over like this. This will take the rest of the paint off. I want all of the bottom of the rail clean, because obviously if I'm going to glue it, I need the glue to stick to it, essentially. So turn that around, get clean a bit. So yeah, clean all this nonsense off. The rails are going to get stuck back down. I may end up repainting the sides of them before I glue them in as well. So I might even actually fully strip this off. But once I've got some wire soldered to it, the electrical connection should be spot on. So that's going to be the next little job. So I'm going to clean this off. What I'm thinking with the wire, I don't want to have to... I want it to be able to come off the slip ring. So what I'm thinking is I'm going to put a little connector in here somewhere. Possibly, I mean, I can easily just glue a little bit of strip board in there and put a connector on it, or I'll use a 2-pin DuPont connector, something that's not going to have any weight on it, so it'll stay put. But so I can undo a couple of bits, lift the bridge off if I need to, and just unplug. And then the space in here, I can put another bit of plastic or 2 across that I can just tuck the wires under. So I'm going to finish cleaning this off, and we're going to be back, and I'm going to try and solder something to a bit of rail. So let's see how that goes. Okay, soldering iron is warming up. I just need to prep these rails now. Now I've marked out a little bit with blue, but I've also filed that slightly just to keep the surface a little bit. So what we're going to do is clean yon soldering iron, bring it back over here if I can persuade the wire on the soldering iron to cooperate. Yeah, this is a problem with soldering iron, but it's a problem with most soldering irons, to be fair, but this one suffers from it as much as all the others. So I just need to bring it over here with a light, and I need to put a blob of solder onto each of these rails where I have marked it out. So just tin the rail a little bit, not that much. Wipe that on there slightly, a little bit more, and then the same on this one. Into here, and it's just a case of getting enough heat into the rail to get the solder to melt on it properly. And I'm just wiping it about slightly. Don't want a massive great blob sticking up, which is the thing. There we go, that'll do. And then I've got a bit of wire here, which needs, these also need tinning slightly, so I'm just going to do that. Get that on there, under there, and then a little bit more in. That's that one. Another one as well. I'm using quite small wire here. I'm going to bend the other one as well, actually. Yeah, I'm using 702 for this. Now, normally you'd use something like 1602 for droppers, which is in effect what these are. These are basically going to become dropper rails. However, in this case, what I'm trying to do is keep the wire quite small, and it'll only ever have a single locomotive on it because it's for a turntable. So yeah, right, let's try and get this here. Turn the soldering iron around so that it's a real pain in the neck the way this iron wire goes. It really is. Right, so that is on there like that. Hopefully. Right. I'll be back in a minute because I'm going to have to redo that wire now. It's got too much of a blob on the end of it. Catch you in a moment. Right. Much swearing later. A rail with a wire soldered to it and another rail with a wire soldered to it. So what we do, have to work out which one is which. So that's that one. That goes through that hole. It does go through that hole. The editor's decision is final on this. There we go. That rail slots into there. And I can get the length positioned right. That one's slightly off. So what I'm going to do is flip it around and use it in this hole and see if it fits here. Again, it will go in. Brute force over ignorance, and I have plenty of both. So that's there. And the rail, it basically, there's a little notch it clips back into, which I just need to persuade it to fit into. It should go in. Is it going in at the ends? This is the thing. There we are. It's in there. In there. Just need to get it to sit in the gap, and maybe there's something in the way. Try the other one. They do fit in because I've had a minute. They were in a minute ago, so I know they do fit. I've just got to. They need to. I need to modify it so they fit easily rather than just it goes in a little bit if you're lucky. Right. See that. That's that one, and it's in flat. It stands a little bit proud of the deck, but only a little bit. And as you can see, I've cleaned the top of the rail off thoroughly as well. So that's basically one of them. That's going to need a dab of glue. And I've got a wire coming out the bottom through the hole like that. So what I need to do is a dab of glue. And what I'm going to use is super glue. I was thinking of using Araldite and super glue. I'm actually just going to use super glue. Reasoning is I do want the ability to break the connection if I need to. So I'm going to put a little bit of super glue in. Hopefully this one is still liquid. I'm going to put a little bit. I'm now going to unblock the super glue. And I'm going to find out it's all solid anyway. So a little bit of super glue into there. Oh no, that it is still liquid. A little bit of glue there, there, and there. Probably doesn't need much more than that. I don't want to use too much super glue. I just need to find somewhere to put that. Right, this one I know goes in, so I can put this in here. Get it in at the ends and then just hold it down briefly, and hopefully I can get the thing into its little groove. Hold it, and that should set. Take it a few seconds, but that's fine. But the key bit here is I'm no longer relying on a friction contact between a spring and the bottom of the rail. It's now a soldered join, so that should be all right. That's going to have to let that cure for a few minutes before I do anything particularly violent with it. Well, I'm going to do anything violent with it because that would be violent, and I'm not sure if the rail has consented to that. Yes. Anyway, never mind. Right. Let's try this one again. Goes in. That. And I just needs to be lined up properly at the ends. That might be the problem. It's just slightly, yeah. I just need to make this end here slightly shorter. So lift up a little. I'll have access to it then. I'm just going to go in with a knife and just cut a little bit off. There we go. Done. Wire's still firmly connected. Which is obviously the next bit to check. Through here like this, through here. And yes, I did have a cat down here. It seems to have disappeared. So it's either gone back upstairs. It would help if I put that the right way around. Yeah, the cat has either gone back upstairs or is somewhere down here I can't see it, in which case I need to find out what she's doing at some point. But yes. So anyway, the split ring is on order. That will be turning up tomorrow. Oh, that fits in nicely now as well. Sorry, slip ring and not split ring. Slightly different things. At which point I can attempt, depending what time it turns up, of course. This is Amazon. This wouldn't be the first time I've ordered something which they've said is going to turn up on a bank holiday and hasn't. So we'll see. Now, incidentally, if you are an Amazon delivery driver, while I do joke about such things, I do actually really appreciate what you do. So that's that. Let's press it down nicely so it's into its little grooves at the ends. Get my fingers off the super glue. But yeah, this should give me a turntable deck which is slightly more robust than I had before. I've still got to drill a hole in the bottom of it. I'm going to let this glue cure properly first. And then when the ring thing is here tomorrow, I'm going to just have a little look on the underneath. I've trimmed a little bit of this plastic back so that this can sit to one side. Obviously, these wires are a little bit long. That's not a huge problem. I need to work out exactly how I'm going to do it. I want the slip ring to be stuck into the base of the unit. So I need enough wire I can lift this out and get it clear with whatever I put there. But that, hopefully, is a turntable deck, and the rails are flush at the ends, which is what they needed to be. The rails are now stuck in. I've just got a tiny little bit of cleaning to do there. And the rails are clean, so just check that in there as well. Right, I'll let that cure. When the ring turns up, I'll get the hole drilled and what have you, and we shall see whether I can get this assembled and working. Here's a quick little extra bit. This is now done. This has got the wires fixed. They go to a little connector block. The center hole has been drilled out. That needs to be drilled out. To do that, I strip all the motor and stuff off the bottom of it. And to do that, I need to lift the board up. Now, since I'm lifting the board up anyway, I've added a bit more cork, and this extra stabling road is going in. I figure, why not? Well, I've got the board up. So the cork is down. I'm going to let the glue on that dry for a bit longer. That's going to get painted. That's going to be left to dry. I'll drill some holes. I've made sure there's nothing underneath where they need to go. I'll put the bit of track in. That's going to dry. And then tomorrow, when the slip ring's here, I can start fitting this. The hole under this is a sheet of plywood. That's got a 24mm hole through it. Now the slip ring's 22mm. What I'm going to do is drill a 24mm hole through here. So I'm going to take this piece here out. Yeah, I'll do that when the thing's in pieces. I'm going to prise it apart. That's obviously slightly too big. I'm going to 3D print a little mount that can sit in here as like a sleeve that basically replaces this, except it's got a 22mm hole in the middle. The slip ring can fit through that. There's enough space under here for it to come up and pick up the wires, I hope. Connectors on here. That's how I'm going to be able to take it apart. I want to be able to lift the thing off. It'll pull the center shaft all the way out with it. I'll have to unscrew it at the bottom. I'll be able to just lift it up a bit, unplug this, and then away we go. These will get a bit of paint on them to key which way is which. At the moment it doesn't matter. Essentially then it's whichever way around it is. Either that or I'll do that and I'll make it so the one on the underside has also got a plug and socket, so if it's backwards I can just swap it over. But yeah, that's what I'm going to do for the rest of today. I've got a bit of painting to do on here when this glue's dried. I've got a bit of tractor lay. Fairly straightforward, and that's going to give me another stabling road. So I'll have one over there, I'll have one here. The coal stage is down there. The signal box is about there, and then the track goes like that. So there's still plenty of space for it. I'll have to get another buffer stop. I've got one of the sleeper built ones sitting around spare. I think I might use that there. I was sort of thinking about, yeah, I could get that a little bit longer. Yeah, this is an off-cutter track. I haven't had to cut anything to make that. I'm just using a spare bit. So I'm quite happy with that. Anyway, on with the show. Right, so, day after. I painted this little bit while I was doing the rest of it. I thought I might as well do that, so I did. So that's done. This track here, zoom in a little bit further. This road here is now in, glued down, buffer stops glued on, wires are in, not terminated. Turntable, a little bit more to it. The deck hasn't changed, it's just the wires. I've taken this central piece out. Now, I've got the slip ring arriving later today. That won't be going in today. It's not least because I need to enlarge that hole. Let's get a ruler. Just want to test something. Whee. Now, this hole is currently about 12mm. It needs to be 22mm. Now, I've got a 22mm hole saw coming tomorrow. So obviously until then I can't do a great deal about it. What I can do though is it's gonna have to be here while I drill it, because I need a way to do it and hold it. I've got to take the stepper motor off the bottom, basically because I'm going to be drilling a hole through the board and I don't really want to drill a hole in that. So this board has got to come out again. While it's out, I can wire this up. Can't wire it into the block detection. This board's only got an 8-channel detector and I'm using all 8 channels. So that will be channel 9. Where the camera is eventually going to be the end of the goods yard. So there will be a couple of roads there. Don't know how many. I've not designed that bit yet. I've got a rough idea. But basically this board's going to need another DTC8 going in, which I haven't got and I don't need yet. So I'm not going to put it in. So what I'm going to do, I'm going to get this out. I'm going to take the stepper motor off. And then I'm going to have a play with the stepper motor. I've got the original driver board, which if you remember from a previous video works, but makes a hell of a noise when it's not turning. I've also got this, which is a TMC 2209, which has not yet been out of its package. This apparently can drive stepper motors much quieter. We're going to have an experiment. First, I need to get the motor off. So I'm going to get that done. And this board, I'm going to wire up this other track. I'm then going to put this board back, basically because it needs to be here to drill it. It'll then have to come out again so I can put the motor and everything back on it. But that's another bit. There's two stages to what I'm doing at the moment. One is I want to get the thing working, twiddle it manually. To do that, the idea is I'm going to put a 22mm hole in here, and I'm going to use the slip ring as a bearing. So I should be able to do that. Stick a shaft of a suitable length on the bottom of this. Put a suitable sleeve in to take the 7mm hole down to a 4mm. Slot this in, wire it up. I should then be able to turn it around. Now, one thing to note, the PECO design out of the box, the LK-55, does reversal of the polarity for you. This won't. This is going to be hardwired. So to start with, I'm going to be able to take a train from there to there to there to there to there and back again. Won't be able to go to that one because that one's wired up backwards. Yeah, because it changes by the time it gets around there. And I won't be able to turn the train round, but I'll at least be able to try driving them on and off, and let's see if that works. I'm going to have to put a control board underneath here. I've got the driver chip. Part of that is now going to have to drive a double pole, double throw relay wired as a changeover, and it's going to have to know when to change it. The obvious solution is you leave it in whatever setting it's in until you get where you need to go, and then you go click or clunk, depending which way you have to go based on where it is. So we'll see that. Anyway, I'm going to take this out. I'm going to take the motor off. I'm going to get that wired up. I'll catch you back at the desk in a bit with the motor on the desk. So, see you in a mo. Okay, here we are on the desk. Now, this is what I'm going to be doing. This is the TMC 2209 stepper motor driver. This should be a lot quieter than the previous ones. In fact, it is quieter than the previous ones. It's actually on the desk running as it stands, rotating 360 degrees one way, stopping, and 360 degrees the other. The previous motors, when they stopped, they squealed. You can't hear this one. I'm really pleased. Now, this is quite a capable little device. Yeah, I've not got it to do an awful lot of what it can do, but this is it in its basic form. So we have the thing. It needs a power supply. This is for the motor. So I'm using a 12 volt, 1.5 amp supply here. When it's on the layout, that'll be a 12 volt, 4 amp supply, because that's what the 12 volt on the layout is. So you have to connect that. Don't connect that until you've connected the motor. Now, the motor coils are here. It's typically these sort of motors. I'm using one with a NEMA 17 mount. They've got a 6-pin connector. The wires they come with tend to only have 4 pins connected because you don't usually use the center taps. You can, you don't need to. So here we have coil A, coil B. If the thing judders or it squeals, check you've got these the right way around. It then needs its logic supply. Now I'm supplying this with 3.3 volts off an ESP32. This can cause a few issues, I've heard, because these things come on boards which are designed usually for 5 volt operation. So they've got some pull-up resistors and pull-down bits and pieces designed to be a 5 volt supply, which I'm not using. However, in this mode, it doesn't matter. There is an enable pin. You have to pull that to ground to enable the outputs. If that goes high, the outputs turn off. You can then turn the motor by hand. There is a step input, and this is normally logic low. You push it to logic high, so it'll go from 0 to 3.3 volts. It's got to be there for at least a microsecond. We'll look at the code I've got in a minute. I'm holding it for 2 microseconds. And it will step when it sees that. So it's not necessarily on the rising edge, but somewhere in that time period, it'll step. And then there's a direction pin, connect to 3.3 volts. It'll go one way, connect to ground. It'll go the other way. and that's it. There are also TX and RX. This thing's got a serial port, so it can talk to you and you can talk to it and send it all sorts of interesting commands, and it'll respond with all sorts of interesting bits and pieces. I've not got that working yet, but for what I need, I don't think I need it. MS1, MS2 do various configuration things, not connected because I don't need them. Clock, I've got no idea what that does. So, yeah. But what it's doing currently, if I can just untangle all the wires, sit it here, it's going. Now, it's making next to no noise. I can hold that, and I can't stop that moving, but I can feel it resisting. This, and the motor's not hot. Previously, the motor was getting quite warm. I mean, it's not cold, but it's not warm. This thing will put current into the coils to turn them, and when it's not being made to turn, it reduces the current to try and just hold position. It'll detect if something's trying to turn it, and it'll up the current to hold it, which is quite nice. I'm gonna have to reprint the mount because I need it to be taller because I've got the slip ring to put on the top. But the circuit for it is that. It's an absolute doddle. There's nothing to it. This is the little board. Comes with a heatsink. You have to be careful when you fit that. Otherwise it'll short out to the pins on the little module, which you don't necessarily want. Well, you don't want. But as you see, there's not much connected. It's got its power. Here is the coil power. It is noted, say you don't connect the coil power without the coils being connected, and you don't connect the supply side over here, the logic side, without the coil power being connected. I may need to have a little think about that and put a tiny delay or some sort of little delay circuit in powering that up. We'll see. I'm hoping powering them on at the same time will work because the ESP32 takes a little while to switch itself on. There's a red LED here that currently doesn't do anything. I've got the hall sensor to connect to this. But this is running. By default, it's 1,600 steps per revolution, and it's very, very smooth. I think that'll probably be fine. I can increase that if I need more. I would need to look up how, but it can do it. So the next step is just have a little look at the code that's driving this. So I'm going to fire up my thingy code. And I'm going to stick this in a little box on the screen, and we're going to have a little look. So that, get rid of that. If we don't make this a little bit bigger. And this is the code. This is all of it. So literally what we're doing up here, I'm defining the 3 pins I'm going to use. Ignore that, that's not actually needed. That was where I was attempting to get the serial port thing to work. Configuring it, serial port is just so I can have it right out to the screen while I'm playing with it. You don't need that. Configures the pins, configures them all as outputs, all start low, so by default the thing switches on. And then down here, start of the loop, send the step pin low, sorry, set the direction pin low, so it'll go in one direction. We do 1,600 steps with a 5, I mean this is a 5 millisecond delay. This is turning a lot faster than it will do on the layout. I've just got it turning like this really so you can see it. So we've got the 2 microseconds on the rising edge, drops back low, waits a little bit and goes around again. That 5-second delay is controlling the speed it rotates at. When it gets to the end, we wait 5 seconds, reverse the direction and go back again. Wait 5 seconds and go back. That's it. So I fairly obviously need to do a little bit more code modification work on that because I need that to talk to the sensor. I need it to talk to the switches I've got which will control it rotating. And I need to set that up. But before I can set that up, obviously I need to get the turntable working again. I'm, however, extremely pleased with this. This is working. It is, as I say, silent, which I'm very, very, very pleased with. And yeah, I can't redesign this until I have got the new slip ring set up. So yeah, so I can't refit this until I've got that set up. I do have that little siding configured, but that's about that. So yeah, I need to wait now for some bits to arrive before I can do too much more. I'll say there's the slip ring, which is going to fit on here. This is going to have a 4mm shaft which comes out, and this will go up into the base of the turntable. In fact, if I just move this out of the way, I'll leave it spinning. I shall get another piece of paper because that one's the ink has gone through on that. Let me just grab another sheet of paper. So yeah, this is it's been an interesting weekend. let's just say it's been an interesting weekend. So what we're going to have is motor like that. That has a shaft that comes out, which is what we've got here. That goes into a coupling. And the purpose of this is to change the shaft diameter. That's 5mm and I need it to be 4mm. I'm then going to have a 4mm shaft come out here. That is going to go into the slip ring. It's then going to come up there a little bit longer. And at that point, it is going to be shrouded in. And here we have a turntable bridge with a train on it. Chuff, 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 chuff. Yeah, possibly with a bit on the back. Otherwise, there's not a lot of point in turning it round. There we go. And here we have the turntable well. And what I'm going to do, below the turntable well, there is a big lump of plywood. And what I'm going to do is embed the this thing here, which is the slip ring. So there's some wires that come out there, and there are some wires which will come up into here to the rails. So that basically becomes the bearing in the base of the turntable. This thing here then goes underneath it and is also a little bit of a bearing. This can handle a little bit of misalignment, but not too much. But the way I do it is I'll get that set up as the bearing. I will fit this to it and make sure it's rotating freely, and I will then screw this to the plywood. I'm going to rotate it slightly on what we had before. It'll have to be slightly taller, and there'll be some wires coming out here which will connect up. And then on the underside of this plywood, there will be, I'll make a little circuit board. It will house the ESP32. This thing's going to get its own controller. I was thinking about tying it into the board controller, but that means that board has a non-standard controller, which I'm not particularly keen on. And I want to be able to drive this thing directly. Not worked out exactly how I'm going to drive it yet. First instance, it's going to be the 2 push buttons on the side with the light coming on when it detects the sensor. Just so I can see that. Once I've got that working, I'll get it hooked up so it's controlled over Wi-Fi, and I can control it via the MQTT system. What I want to be able to do is say, go to road 1. Because what we've now got, we'll just do that, turntable. I have a road that goes out there to a buffer stop, one there, and one there. Output road, input road. Now, basically, and over here somewhere is a calibration point. That I'm going to call point 0. And we're going to have 1, 2, 3, 4, 5, 6, 7, and 8. So 1 would be that end, 5 will be that end. So say go to position 1, your train comes on, go to position 5, it'll do 180 degrees and the train can drive off again. That's the idea. So what I want to be able to do is send this thing a signal that says calibrate yourself. So it'll go around and it'll find position 0. And I just want to be able to send it a number, say 1, 2, 3, 4, 5. Essentially, it's going to be one end. And it'll line up there, 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 and there. But I can see which way around it is. That's the idea. I'm going to have a little display board set up for this so I can see it, a little mimic panel, which is going to look something like this, with a bunch of LEDs, 8 LEDs around the edges. And originally I was going to have only 6. I was going to have a red one in the middle, and the red one says, I am not aligned with anything, do not drive onto me. So that seems like a useful thing to have, so I'm going to do that. And that's where we're going with it. So I've just got to wait for some bits to come in. We'll go back to the layout and see how things look. And that is that. Catch you in a sec. Yeah, so here we are back on the layout. Siding's in, this one's in. This is now wired up, as I said. All been painted. Wires for the switches here. And if we go underneath, you can see the motor is missing. This is the connector for the turntable. I've also put the 12 volt, 5 volt and DC ground onto that connector. So that's relatively straightforward to hook up to now. But yeah, that's it for this video. Turntable playing. I broke it. Yeah. Hopefully it's going to be a lot more reliable when it's finished. So I'll just connect these power wires up. I say I'll have to connect a relay, and then the software, when it says go to position 1, will go there, and it'll go click. It'll know positions 1, 2, 3, 4, 5, 6, 7, 8, which way the relay has to be, and it'll just work. The idea being, I can stand down there or at the desk, and I can say, do this. So I can send a locomotive down here, onto the table, spin it round, drive it back off, without having to come down here, hopefully without having to come down here to nudge it, and without having to come down here to twiddle the turntable myself. All the wheels and that are off it at the moment. They're sitting in this little red wagon down here. I do find open wagons remarkably useful for this sort of thing. But anyway, that's it for this video. I'm going to return to this as and when the bits turn up, hopefully in the next day or two. Ideally, I want this working by next weekend. The goal is at least be able to come down here, press that, have it turn one way, press that, have it turn the other. And I'll mount a little LED in here for when the sensor, which is there, magnet, and it's about there. So when this goes round to about there, ding, a little light down here should come on. And it'll be on for a few degrees. So what I'm going to have to do is rotate that way. Ah, found it. Go back a bit, check it. Right, that's my 0 point. I'm always going to go in one direction to find the 0 point. That should work. But with that, yes, that's it for this one. As usual, comments, etc., more than welcome. Yes, this is needlessly overcomplicated. I don't care. I enjoy overcomplicating things. There's all the trains at the back. But yeah, I'll be back in the next video. We'll have some trains moving again. I'll clear some of this garbage off as well, I think. With that, I'll leave you. I hope you had a good bank holiday weekend, and I'll catch you in the next one. Thank you very much, and goodbye.